Okay, today's circumference and arc length. This first part here should be reviewed for everyone. Arc length is the new stuff. All right, we are going to start off with the review, not only circumference review, but arc measure review as well. All right, so draw your circle. Your center in it, and I'm going to draw a diameter going across this way, and I'm going to call that IG. Diameter IG. Now I'm going to draw a perpendicular line right down here. I'm going to call that J. I'm going to draw one more right here. Call that H, and this angle at the bottom is 145 degrees. All right. Knowing what we know about these type of angles, 145, this angle in here, what is this angle called? It does have a special name.
Major arc.
This is not a major arc because it's smaller than 180, and it's a minor arc. But I'm looking for a more specific. What kind of angle? That's what I'm looking for. Thank you. Obtuse is correct. Thank you. Obtuse is, central is what I was looking for. It is a central angle. Do you guys see that? What did we learn about central angles and their arc measures, the corresponding arc measures? What did we learn about that? They are, so this is 145. Do you agree?
Yeah.
If this is 90, is JI also 90 degrees and degrees? All right. Number one, again, this is review. M, J, G with that. Do you guys remember what all this notation means? What does the M stand for?
Measure.
Measure, and this bumpy non-line piece, arc. The measure of arc JG. Is JG a major arc or a minor arc? For example, can I do this for JG?
It's a minor arc.
Because there's only two letters, I cannot go around on the major side. Do you see that? So I didn't give you a number in here, so how do I know what the arc is? Don't blurt it out. Think about it and write it down.
I got it.
Give me just a few more seconds. What's your question?
It's about, okay, so what if it was like, so instead of it, what if it was HGJ? That would be minor.
HGJ. No, that would be the major. Because you go. HGJ. Yes, and we had that one. It was on homework somewhere where it did that, and you can use 3 letters for a minor arc, but you cannot use 2 letters to name a major arc.
You could just even say HJ.
Right, right. All right, what was that, Mendoza? All right, anybody have the answer?
Yeah.
What is it?
It's 90.
90 degrees. Anybody else can explain how he got that it is 90 degrees?
The IJG is 180.
Mm-hmm. He said IJG all the way around 180. Keep going.
They do 180 minus 90, or just 290 plus 90.
Mm-hmm. And you get this. Do you guys agree?
Yeah.
All right. Because he's saying this whole arc here is 180 because it's a semicircle. And so he did 180 minus this here that's 90, gives you the rest of this, which is also 90. Did anybody use the linear pairs? So if this is 90, then this is 90, which means the arc is 90. Does that work as well? Yeah. Okay. All right, number 2, GH. The measure of arc GH. I'll let you guys do that one on your own without any talking. GH. Is that the major GH or the minor GH? Minor, because if it's only 2 letters, it cannot be a major. All right. Anyone have an answer? Hands up. What is it?
35.
35? All right, can I have somebody explain? It is 35. Can you tell me how you gave the right reasoning. Can you tell me what it was, Mendoza?
180 minus 145.
Can you tell us why?
Then it's minor, so you do, so IJ 140, and half is 180.
Okay, oh, okay. So yes, he's saying this is the semicircle 180,
Yeah.
and we're looking for the minor piece. If the major's 145, take 180 and minus the 145. Do you guys agree? Did any of you do that as linear pairs and said 180 minus 145 is 35, which means the arc is 35?
I just added up all the ones that I knew and subtracted.
Good. Okay. Did anybody do it that way?
Yeah.
He said he just added up the ones he knew. So he put 90 plus 145 and took all of those and subtracted from 180 or 360?
360.
Because he's going all the way around. He said, I know everything except that wedge, so add up everything I do know and subtract it from 360. Did it give you the same answer? Okay. Questions? Number 3. The measure of arc JGI. I'm going to have you guys try that one on your own. JGI.
It's 270.
All right, I heard 270. Can I have a volunteer raise their hand and explain? Yes. Okay. Okay, one more time and a little louder. Thank you. All right, he said you take the 90 plus the 35 plus the 145 and you add all these up together and you get 270. How many of you did it that way?
Yeah, you
Yes.
realize that that's a semicircle, so you use 290 plus 1.
Okay, so you said that you can realize that what? Say it again.
The IHG is a semicircle.
IHG is a semicircle, so do what?
You just add 90 to 180.
Okay, so 90 plus this whole half of 180.
Yeah.
All right, anybody do it that way? Recognize that this is all 180 plus 90? Did anybody use 360 and minus? Yes, can you tell me what you guys did? 360 take away this 90 because this is the one corner that's not in there. Do you see that? JGI is everything except for this one. Please stop, gentlemen. So they did 360 take away 90. All right, any questions? Okay, last one for this review. Measure of arc IGH. I'll let you guys try that one on your own. IGH. Adam, do you have it already? You have it already?
Yeah.
Can you tell me what it is? Loud. 215. Can you explain how you got 215 for IGH? Good. Can you tell me which ones you added? I assumed you were done because you were just sitting there. Okay, let me trace for you what we're finding. I to G to H. So these three here, 1, 2, 3, are the ones that I'm collecting as I trace from I to G to H. So which ones should you add together? 90 and 90 and what? 35. 90, 90, and 35. How many of you did it that way? Any of you do 180 plus 35? You saw that 90 and 90 is 180? Did any of you do 360 minus 145? In the end, did you guys all get the same answer? All right, any questions? I saw this mistake, or at least it was asked yesterday when I was walking around. IGH, kids are doing this. It wouldn't work on this one. JGI. They were doing this. JG and then cutting across. I'm hoping nobody did that. Like, you should not be cutting across your circle.
That would make sense.
Yeah, you're going around the arc on the outside. Okay, questions here on this review before I move on? Okay, next section is also review, not from this class, but from prior math classes. Circumference. back in elementary school, in middle school, in Math 1. You did circumference over and over. Please put your phones away. You're paying attention up front with the rest of the class. All right, who can tell me what the circumference, what it is? What's the definition? What would you say circumference is?
It's like the entire outside of the circle.
Okay, so the entire outside. So let's say the length around the circle. Now, how is that different from arc measure? Is there a difference between arc?
Yeah, it's different.
Are you guys done?
Yeah.
Can you please leave them alone? Is that a yes? Okay. There's a difference between arc measure and arc length. Do you guys hear, first off, how they sound the same and how they're different? Arc, they both start with arc measure, arc length. Arc measure is equal to its central angle. So they always come out in degrees, 90 degrees, 35 degrees. When you're looking for the measure of an arc, it will always come out in degrees. When you're looking for an arc length, it's going to come out in like feet or meters or inches. Why? Because the length is going around the circumference. Let me show you what I'm talking about. First off, what's the formula? Anybody remember circumference back in elementary school, middle school? Pi times
R, or
2 pi r,
2 pi.
pi times diameter.
Ah,
Pi r squared is a formula, but it's a formula for what?
Is that area?
Area, and we will deal with that one tomorrow. Jeez. Okay, so pi diameter, or 2 pi r if that's the way you've learned it. Okay, so here's what I was talking about with measure and length, the difference. Okay, if I have this circle and I gave you that the radius is 4.2 meters, and then I asked you to find the circumference, is it correct to say the circumference is 360 because I'm going all the way around?
No.
No. If I asked you for the measure of the arc all the way around the circle, is it okay then to say 360?
Yes.
Yes. But circumference, imagine if you have a circle made out of string and you just cut it at one point and then you laid it out on a ruler and you measured that length, that's what your circumference is. Do you hear that? So you have a circle made out of string, you snip it, you lay it out on a ruler and you measure the length, that's what your circumference is. That's not always 360, that's when you're dealing with the measure of an arc, not the length. Do you see the difference? Yes?
Yes.
All right, so if I did ask for the diameter, which I'm going to, number 1, find, not the diameter, the circumference. Find the circumference, such a long word, find the circumference in terms of pi. All right, when it says in terms of pi, it means pi will be in your answer. Do not plug pi in your calculator. So this is review. Circumference equals pi times 4.2. No one's going to stop me?
Oh, wait, no.
Okay, why are you stopping me?
Wait. There's not really a different cross.
Good job.
Yeah, that's right.
Now I asked, is anyone going to stop me? Before I asked, did anybody catch it?
Yeah.
Yeah, you're just waiting. Like, wait, is she really putting that down? All right. So the 4.2 represents the radius. What is the diameter?
8.4.
Okay, so is it okay to put 4.2 in here? Unless you put 2 times 4.2, but by itself it's not okay. 8.4. Now, typically we write the 8.4 in front of the pi. It's okay if you don't, but this is the way you're going to see it. When you're looking at answer keys or grading work, you're going to see it like this. Multiple choice answers, you're not going to see it as pi times 8.4. You see it as 8.4 pi.
why can't you multiply it?
Because it said here, find in terms of pi. Good question. He said, why wouldn't you multiply it? If they tell you to leave your answer in terms of pi, should you be multiplying it out in your calculator? The pi. The pi should actually be in your final answer. Now, technically, is my answer 8.4? No. It's in this whole number is a number hiding in our calculator, which we're actually going to find in number 2. I'm going to put this here. Yes.
Has anyone ever found the solution to pi?
There is, I don't know what you mean by solution, like,
Cause like I heard like it goes on and on and on.
there
and on.
is no ending to pi. So has anyone found it? No, because there's no ending. It goes on forever and ever and ever and ever. And ever.
Theoretically, you can.
And ever and ever. Yeah.
Endeavor.
Okay. Find the circumference as a decimal. We're going to learn more about that as far as rational and irrational number goes. Pi's irrational because it goes on forever, non-ending, non-repeating.
Oh yeah, just keep on repeating. I remember that.
Yeah, so there's no repeat, there's no pattern, it just goes on, non-ending, non-repeating. We'll learn more about that in another unit. All right,
Like space.
find the circumference as a decimal. We'll put 2 decimal places. All right, so we already have it here, 8.4 pi. How do you plug that in your calculator?
8.4 times 5.
Okay, 8.4 times what? 3.14? Okay, I heard 2 things. I heard 3.14 and I heard there's a pi button. Okay, if you have the pi button, I'd like you to use it. I will tell you, using the pi button gives you more of an accurate answer. And sometimes they come out the same, sometimes they're a little off depending on how many decimal places. Okay, if I use 3.14, what do I get to 3 decimal places? I'm sorry, 2.
26.37.
0.3, after the 7's a 6, so 0.37 or 38? Okay. Do you see that?
Wait, so wait, I have a question.
You get 26.39.
Is
Yes.
it because I don't understand like why is it that we use pi for finding the the circumference and all this?
Yes,
stuff?
mathematicians many moons ago, before they realized what pi was, when they were working with circles and doing math, because they did do math with circles,
Yeah.
and everything they did, they kept finding this 3.14 blah 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 that went on, and it kept coming up, and then they were like, oh, there's some relation, and they found that.
Is it because because it goes on like infinite? You times it by a certain number, it would come up with. I don't understand how.
Well, right now I didn't use the infinite form of pi. I used 3.14. So let's use the pi key, and even my pi key doesn't go on forever. It can't on the calculator. So 8.4. Your pi key is right here on the left side middle. Shh, guys, phones put away. Pi key is right here. So 8.4 pi, and do I get a longer decimal? 2 decimal places. 26.38 or 39? All right, so I will accept either of these, and yes, you're going to say, well, what if I have 26.37? No, it's one of these. Okay, got it? Questions? Okay, which one's more of an accurate? This one here, because we used our pi key. All right. Yes. Hustle, please. Okay, I'm moving on.
Wait, what goes in those parentheses? In those quotations?
Oh, find the circumference. Yeah, guys, these quotes, I don't want to write it all over again. It's this: find the circumference as a decimal.
Why did you put a line under it?
I did to put an arrow there.
Because it's a vertical.
All right, moving on. Now we've reviewed circumference, we reviewed arc measure. Now we're moving on to the new stuff, which is arc length. And this is what the test is going to test you on. Are you ready? Too bad. Oh. All right. I will tell you this. I'm going to pause this. I will put it back. These are review questions, and these review questions will be on the homework today, but not so much on the test. This new stuff here will be the new stuff that's definitely on the test. More of these than those little review problems in the beginning. I'll get you your assignment sheets in just a bit. Okay. Arc length is a fraction of the circumference. Arc length is a fraction of the circumference. What in the heck does that mean? Arc length is a fraction of the circumference. Okay, not necessarily a half, but a piece of. I'm gonna move this. I will put it back. Okay, so remember when I talked over here about the difference between circumference and arc measure? Arc measure, yes, is 360 all the way around. Is that true for circumference? No. Now, arc length, as it says here, is a fraction of the circumference. And the circumference is the length around the circle. So somebody said cutting it in half. Yes. So imagine you had scissors and you cut at that end and laid it out, finding the length.
They cut that in half.
And you can cut that in half. And so take a piece, and it doesn't matter how, we're going to learn how to do it in a little bit. If you cut those two pieces out and laid those two pieces out, or that one piece, this string right here, on a ruler, and you measure it, that would be your arc length. Got it? So do you understand now the difference between arc length versus arc measure? Arc measure will always come out in degrees. Arc length will always come out in inches or meters or feet, which reminds me, I forgot that over here in my circumference. What should I have here? 8.4 pi what? Meters. And I forgot it down here as well. 26.39 or 38 what? Meters. Okay. Shh. Why are you being mean?
It's just a friendly conversation.
You're just being mean.
Friendly
You're acting like the fashion police.
Yeah, yeah.
Arc length. All right, it's a big formula, so make sure you're ready. It will always be your arc measure divided by 360. And I'm going to pause there. There's more to it. It will always be your arc measure divided by 360. Now we're going to times by the circumference. All right. Arc measure over 360 divide by times by circumference. Okay. Arc measure. 360 is all the way around the circle. Do you agree?
Yeah.
Arc measure is just going to be whatever the measure of this arc is. What do we know about arc measure? Arc measure is always equal to the central, we said it earlier, what was the word? Central angle? Yes? All right, so I use the word arc measure. Is arc measure equivalent to central angle? Yes? So those could be used interchangeably. All right, I'm going to tell you right now, this unit's heavy on formulas. Heavy. So work on them now. Do not wait until the end because you're going to struggle. All right. Find the length of the darkened arc. All right, and I underlined length because I'm not asking to find the measure, I'm asking to find the length, and yes, it does make a difference. Okay, here's the circle, here's my center, and I'm going to cut off this section of the circle. I'm going to darken in this arc up here. I'm going to call this 6 feet. I'm going to call this 100 degrees. All that information will be given to you. Okay, so again, imagine the circle's made out of string, and I cut here and here, and I take this darkened piece off, and I take it to my ruler, and I lay it out, and I measure it. That's the arc length. I snip and I snip, lay out on my ruler, and I find the length. That's the arc length.
What does that say beside 6 feet or 100?
100. Yeah, that's 100 degrees. All right. Now, according to this formula, I'm going to use arc measure. I gave you the central angle, not the arc measure. Are those the same thing? Yes. My question is, over my formula, I said arc measure, but I didn't give you the arc measure. I gave you the central angle. Are those two things the same?
Yeah.
Yes. So you can put the 100 there, or you can just say, hey, I know arc measure is a central angle. It's up to you and how you want to do it. All right, here we go. And again, if you're not trying and working with me, you will struggle hard on this test. And this is the first full test of the semester. You do not want to be off to a weak start. All right, I do not need this fraction that big. Okay, so arc measure. What's the measure of this arc? We just talked about it. Over, what's the denominator always going to be? 360 times the circumference. What's the formula for circumference? Pi times diameter. So pi is my diameter 6 or 12? 12. Okay. Would you rather use tape? No. Would you rather use tape?
No, it's fine.
Okay. Okay. So this is where kids struggle. Like, how in the world do I simplify this? I'm going to give you tools to do it, and it's up to you on which tools you use. Are you ready? First tool is when you learned in elementary school. What can you do with these excess zeros over here? Make this as easy as we can. So this becomes 10 over 36 times 12 over 1, and then I'm just going to tag the pi in at the end. And if it doesn't tell you which way to write it, leave it in terms of pi. Only put it as a decimal if it says write as a decimal. Okay, now I'm going to ignore the pi and I'm going to focus here. What can I do with the 12 and the 36? Cross reduce. Yes? I'm going to cross reduce. What goes into 12 and 36? Does 12 go into both of them? 12 goes into itself how many times? And into 36? 3. So I have 10 times 1 over 3 times 1. What does this give me? 10 over 3, and then your pi's at the end, and that's your answer. How many of you feel like, I can handle that, it's not that bad? How many of you feel like, ooh, fractions scare me when I see them? We are going to do one more. Before we do the next one, I do want to say this. I want to show you how to plug it in with your scientific calculator, and it's totally up to you and how you do it. Are you ready? Yes. That was a tool you learned in elementary school. Like if there was two, like I couldn't cross out that 0 because that's not a 0. You don't have to use that trick. It just makes the number smaller and easier to plug in.
I guess it doesn't matter then if you like knock off the 0, but it doesn't matter.
If you didn't, then you would have this 100 over 36 times 12, and then you would still reduce, and you'd have more reducing at the end.
Okay.
Okay. Now, are you guys ready for me to show you how to plug it in your calculator? Because you're allowed to use them, is it a tool that you should know how to use? All right. So this is what I'm going to type in my calculator because I like to cross off the zeros, but you don't have to. I'm going to type this right here without the pi. So 10 fraction 36 times 12. I don't need to put the fraction there. Okay. Turn your calculators on and clear. Are you ready? Now, for me, on my calculator, my fraction key is right here. On yours, it may look like this. A, B, C is your fraction key. Mine looks like this, N over P. You're looking for one of these keys on your calculator. Mine's right here. Yours might be like over here on this side or up in this area. Everybody find the fraction key. Different calculators type them in different ways. Some of you, when you type in it, it'll look like a comma. Some of you will look like a fraction slash. Some of you look like a horizontal fraction. It just depends on your calculator. All right, are you ready? Okay, 10 fraction 36. And I'm going to hit clear, I'm going to hit mode, and I'm going to get to classic because I'm assuming that's what all of you are in. Okay, I'm going to do it again. 10 fraction 36. Do any of you have the fraction that looks like this? How many of you have a fraction that's a horizontal line? How many of you have a fraction that has a comma? It looks like a comma. Okay, they're all going to work the same. For me, for this one, and for those of you with the comma, you can go straight to times. If you have one that's a horizontal line, you'll have to hit the right arrow to get out of the denominator. Okay? I'll show you what I mean in just a second. What am I going to multiply by next? 12 equals, and do I end up with 10/3? Yes? Yes. Does that make sense? All right. I'm going to show you just in case you have a different calculator. Okay. So fraction, what was it? 10 fraction 3. Now I can't hit times 12 yet. What do I have to do to get out of the denominator? Right arrow. and then times 12 equals. And obviously I messed up because I put 10 over 3 and it should have been 10 over what? No, 36, thank you. 10 over 36, right arrow, times 12. And I was just going too fast. We don't put pi. We leave pi until the end because pi is part of our answer. We don't plug it in the calculator unless it tells us to. And if it doesn't, then we don't. All right. Do you guys understand how to use your calculators? Now, if you don't have one of these, can you just do it by hand the way we did earlier? Yes. All right. I'm going to give you one more just to plug in quickly. Number 2. Here's my circle. Center at A. And I'm going to darken in this piece on the back, the major arc instead of the minor arc. I'm going to give to you that this is B, this is C. I will also give you that the measure of arc BC is 30 degrees. This is 10 inches. All right. We're going to have to get to this quickly. Are you ready? Arc length equals. Okay, something over 360. Arc measure. For this one, do I use 30, yes or no?
Yes.
No, because is 30 the darkened arc?
No.
Everything else is the darkened arc. Who knows what the darkened arc measure is? Can you tell us how you got 330? If this is 30, 360 take away 30 gives you the remaining arc. Do you guys all agree with that? Okay, that's why we did the review first. All right, times pi times diameter. Is my diameter 10 or 20? 20. All right, I'm going to use the shortcut that we learned in elementary school. What can I do here with the zeros? Now, you can't always do that, but when you can, take advantage of it. 33 over 36 times 20 times pi. When you plug this in your calculator, will you be plugging in the pi key? So practice. 33, fraction 36, right arrow or not, depending on your calculator, times 20. Do it now. 33 over 36 in your fraction key, right arrow or not, depending on your calculator, times 20. Can everybody do that now? Or you can hit 20 times the fraction if that's easier for you. I like doing it that way. 20 times 33 fraction 36. Anybody have it?
Yeah.
Give it to me. 55 over 3 pi inches. Anybody get it as a mixed number? 18 and 18 and 1/3. Nobody got it that way?
I didn't try yet.
No, you don't have to. It just depends on your calculator. Different calculators give it different ways. All right. Any questions? Make sense?
Yeah.
All right. You guys